Hello, I'm Will Starkey, and this is my Lab 1 presentation for Physics 2212. So to introduce the lab, our main goals are to analyze and understand the interactions of charge between two charged pieces of tape. Then we are going to model the same thing in GlowScript and see the charge of the tape using the computational model, and then we will predict the change of the charge of the tape with the first. The results, we found out that the tape was charged positively, and that the charge of the tape was 8.66 times 10 to the negative 9. Physics principles we are mainly going to use is the force of gravity is equal to mg, and then the force of the electric force. So we can see, we know the force of the gravity of the tape has to equal the electric field holding the tape up in the experiment. So all we have to know is the force of gravity using the force of gravity equation on the left, then the force of the electric field with the right. For our calculations, we first have to define our system, which was tape B, and our surroundings, which we decided to be tape A. The tape length was 17.2 centimeters, while the tape weight was 0.172 grams, and the distance between the two tapes was 20 millimeters when tape B was elevated due to the electrical charge. So the math, we can see that we just use F equals mg, and we found that the force of gravity was 0.00169. Using what we know here, we now know we can just plug that in to or set it equal to the force of the electric field. So therefore, we know it is equal to K times Q squared all over R squared. And when we solve that, we get that Q is 8.66 e to the negative ninth. Now, if we go to our computational model, we wrote out our same initial conditions with some being a little more precise. And then using that, we just calculated R using our distance, our gravity with the same way we did before, and the electric field being the absolute value of that gravity, because we know that's what it equals. Then we just set that equal to the electric force equation, and then we got our charge back, which in this case, we can see that the charge on one piece of tape happened to be 2.710, all those numbers, times 10 to the negative 8th. And to do this computational model, we had to make a few assumptions, and that was that there was no air resistance, the charge on the tapes were point charges in the center, and that each tape had the same amount of charge. So after all this, we can see the similarities between the model and our real-world observations. Both were calculated with the same method, but the difference is the answers were off by a little bit. I think around 2 times 10 to the e negative 10th. So we can see that the more exact numbers in the computational model and how it calculated it led to a more precise answer and got us that different answer. But there were some sources of error with the human and the analytical method, along with computational. When we are getting our data, there of course is human error. When you have to read the measuring stick to spy the distance between the two tapes, we can tell that there's going to be some human error in our sight, and it's not going to be an exact perfect calculation. It's also not perfect calculations in our weights when you're measuring the distance of the tape. Then also there's calculation and sigfig errors. As you can see, the code has far more significant figures, so it's going to be a more precise answer. In conclusion, we can look at some of the what ifs and the whys of this lab. For the what if the charges of the proton and electron were switched? Well, nothing would change in terms of our experiment, only the sign of the charge of the tape and what it would charge would be. So the tapes would still repel each other and they would still have the same magnitude. It's just the proton and electron would have a different sign. So whichever one is subtracting slash repelling would be different. Now, why would the tape lose charge if it was in contact with our hand? We don't want the tape to contact with our hand because the tape will lose its charge over time. Because this tape does not have a permanent charge. We charged it when we ripped the tape off from the table. So we know that the charge will slowly wear off, and when coming into contact with things like our hand, that removes some of the charge. And that is it for my lab 1.